All right, so we're going to still find the same things that we've been doing, but then in the end, we're going to put them on a graph and see what the graph is going to look like. So can you guys tell me what the horizontal asymptote is, for example, one? I know you can. What do y'all think? Y equals 2. Good. Because the degrees are the same. We're going to do leading coefficient over leading coefficient. Right? Does this one have a slant asymptote? No. So if there is a horizontal, there's automatically not a slant. But if you were told only to find the slant, how do you know if there's a slant asymptote? The numerator degree is exactly one more than denominator. Very good. All right, what's the y-intercept? Yeah, 0, 1/4. So make all these x's 0, so they basically disappear, and you're left with -2 over -8, which is 1/4. All right? What do we have to do to find the other 4 things? Factor. So you guys go ahead and factor it on your own, please. All right. So what numbers are not in the domain? Very good. So we just look at our denominator factors, and whatever would make them 0 is not in the domain because they are either going to be holes or vertical asymptotes. So does this graph have a hole? Yes. And so because there's a common factor right here, it creates a hole in the graph. So that's why 2 is not in the domain, because there's a hole. It's an empty point. All right, so we cancel out that common factor. We get a new reduced function that we can use to find points on the graph and find the y part of the hole. So it's like our y part of our hole is going to be 5/6. Does this graph have a vertical asymptote? What do y'all think? Does it? Yes. So whatever would make whatever will make this equal to 0 is where the vertical asymptote is. Exactly. What's left in the denominator after you reduce gives you a vertical asymptote. What does what's left in the numerator after you reduce give you? The x-intercept. So whatever makes that 0, which is -1/2, is the x-intercept. All right, so I'm just going to go through the list starting on the left and just graph all the things that we found. So we're going to start with, well, someone asked me last period, like, why is the vertical asymptote x equals a number and the x-intercept just a point? And that's a good question. The vertical asymptote is x equals a number because it's the equation of a vertical line, and that's what vertical lines are. It's x equals a number. And then the horizontal asymptote is y equals number because it's the equation of a horizontal line. All right, so I'm going to start with that horizontal asymptote, and I'm going to go to where y is 2, and I'm going to draw a dashed horizontal line. That's how you graph a horizontal asymptote. Then I'm just going to go down. There's no slant, so we're going to graph the y-intercept. So it's just a point on the y-axis at 1/4. All right. Then we don't graph the domain. Then we go to the hole. So we're going to draw like an open circle, like a hole in the graph at 2 5/6. Okay. All right, and then for the vertical asymptote, we're going to go to where x is negative 1/4. We're going to draw a dashed vertical line. And then finally, on the x-intercept, we're going to put a point at negative 1/2 on the x-axis. All right, I'm going to redraw my hole because it looks kind of weird. There we go. Okay. So what happens with asymptotes is the graph is just going to get closer and closer and closer to them. So I'm going to start at the bottom right. So I'm going to start about right here. We're going to be close to the vertical asymptote, and I'm going to curve through those points. And I'm going to go through the hole also. And then I'm going to go close to the horizontal asymptote. So it's going to kind of go vertical at the vertical asymptote and then go horizontal at the horizontal asymptote. So that's one branch of my graph. But this has at least two branches. So this is just one side. There's something else that's going to happen on the other side of the vertical asymptote that we don't really know. Like we don't have any points over there. But it's okay. We can find some more points. Just like we found the y part of the hole, we're going to use that equation and just find some more points. And you can find as many points as you want to. And you also can use the original equation. It's just a little easier to use the reduced equation. So what we need is some points on the left side of the vertical asymptote. Okay. So our vertical asymptote is at -4. So we need some points on the other side, at the left side of it. So I'm going to put in -5 and see what happens. All right. Now you can do that in your head. I'm going to write it down just in case you forget what we did. It's up to you. You can write this down or not. Sorry, we're doing -5. All right. So it looks like in the numerator, you're going to get -9. In the denominator, you're going to get -1. So that's a point at -5, 9. All right. So it's going to graph that point over there. All right. And let's go ahead and find another one. Let's just plug in -6. It's not hard. All right, so it looks like we get -11 over -2, which is going to be 5.5. All right, so I'll graph that point. Okay. So you can kind of start to see what's happening. You can keep plugging in points if you want to, but I know that I'm going to curve through these points and then it's going to kind of start going flat with that horizontal asymptote. And that's that graph. And someone in my last class says, why is there not a hole on the other side? Well, there is only one hole in this graph, and it's right there because there was only one set of common factors. That's the only thing that creates a hole. So that's it. All right. Do you guys have questions on this graph? Okay. So I'm going to let you guys do all those things on your own, and then we'll come back and graph them. Right, so when you do that slant asymptote, make sure you fill in a 0 for the x squared. I mean the x, sorry, that was missing. Yes, ma'am. Did you have a question?
I don't know. In the domain it says x is not equal to, then the vertical asymptote is x equals to.
Mm-hmm. Because that's not in the domain. That's not, like, those dashed lines aren't part of the actual points on the graph. So the graph, like on this one, the graph is never going to get to actual -4, and -4 is not in the domain. So those things that are not in the domain are either where your vertical asymptotes are or where the holes are. All right, so here we go. Let's graph these things. So no horizontal asymptote. The slant asymptote is going to be graphing the line y equals x plus 2. That has a y-intercept of 2 and a slope of 1. So from 2, we're going to go up 1, right 1, up 1, right 1. So that's your dashed slanted line. Right, and then the y-intercept is at 4.5. That's the x-axis, sorry. All right. We don't have a hole to graph on this one, but we do have a vertical asymptote when x is 2. And then we have 2 x-intercepts. Okay, so our graph is going to be close to the slant asymptote over here on the left. And then it's going to curve through these points and end up close to the close to the vertical asymptote. Okay, and then it's the same thing on the other branch. So these, remember, you can't connect points across the vertical asymptote. So we have something going on one side of the vertical asymptote and then something else going on the other side. So we're going to start close to our vertical asymptote, and then I'm going to curve through that point and end up close to the slant asymptote. All right. What questions do you guys have on graphing? Okay, so I have an assignment to give you.